Good morning everyone. My today topic is single phase AC voltage controller with RL load. This is the circuit diagram and here we will draw the output waveform. In this lecture we will study the working of circuit diagram, how to draw voltage waveform for V0, I0, T1 and T2, thyristor voltage T1 and thyristor voltage T2, and derive the output voltage equation. So let's start. The working of the circuit diagram is same as in the single phase AC voltage controller with R load. Let's see what is the difference when L is connected. This L is connected. So this is thyristor T1, this one is this thyristor T2, this one is R, this is L. This is input voltage Vs equal to Vm sin omega t, and this is Vt1 plus minus, and this one is Vt2 plus minus. Voltage across thyristor 1 and voltage across thyristor 2. Thyristor 1 only will trigger in positive cycle and thyristor 2 only will trigger in negative cycle. You cannot trigger thyristor 2 in positive cycle and thyristor 1 in the negative cycle. Because when the voltage is positive across this terminal, then T1 only will be only in forward blocking mode, and when this terminal is positive, T2 only will be in forward blocking mode. So suppose for theta equal to alpha, for positive cycle theta equal to alpha, T1 is triggered, then output voltage will be like this. And due to inductance current will increase slowly and decrease. It will not increase as in the when only R is connected. Due to inductance it will increase slowly and decrease slowly, like this. So from here this is pi, this one is 2 pi, and this one is 3 pi, and this one is 4 pi. So when current is increase and decrease, it crosses the point pi. That means that current is present from 0 to some angle more than pi. So at this time from here to here, this thyristor is on, so output voltage will be seen like this. Okay? Because thyristor on है, T1 on है, तो जब तक ये on सर्किट कनेक्टेड रहेगा, फिर पॉजिटिव साइकिल के करंट कैसे फ्लो करेगा? Like this. और पॉजिटिव साइकिल करंट will flow like this. तो जब तक ये ऑन रहेगा तब तक V नॉट इक्वल टू Vs दिखता रहेगा. सो इंडक्टर की वजह से T1 थोड़ी देर और ऑन रहा, तो आउटपुट अब ये प्लस हो चुका है, ये नीचे टर्मिनल नेगेटिव हो चुका है, ये पॉजिटिव हो चुका है, अब ये नेगेटिव हो गया है. ठीक है. सो T1 ऑन है तो इसके क्रॉस जो वोल्टेज दिखेगा, कौन सा वोल्टेज दिखेगा? ये नेगेटिव वोल्टेज दिखेगा. नेगेटिव वोल्टेज कितनी देर के लिए? इतनी देर के लिए. ओके. देन अगेन at this point energy of the inductor is released to the circuit. Why it's increase slowly and decrease slowly? Because inductor cannot allow the sudden change in current across it. You also can say that rate of change of current is avoided by the inductor. Sudden rate of change of current is avoided by the inductor. So at this point inductor energy is reduced, so output voltage at this time is 0, because thyristor gate 1 T1 is turned off, output voltage is 0. After angle count from here alpha, T2 is triggered, then output voltage will be like this. Output voltage will be like this, and current from here to here, current is 0 because output voltage is 0, so current is 0. Now for negative cycle, current will increase in negative and again decrease and become 0. So current is present from here to here, so output voltage will be present from here to here like this. Again for a positive cycle, T1 is triggered here, then output voltage will be same as input voltage, and current will increase in positive and decrease like this, same current again like this. So and draw this. Okay, this is the output voltage and current for AC voltage controller. Now let's draw the voltage across T1. Okay? So when this terminal is positive, and thyristor T1 is not getting on, so that time voltage appear across it same as the Vs. Now when T1 is on from here to here, you can draw here like this. That here also. Okay. So when T1 is on from here to here, and T2 is on from here to here. So when T1 is on, at that time voltage, this is positive, T1 is on, and voltage across it is equal to the potential drop across it. Potential drop, what is potential drop? Potential drop due to impedance offered by the thyristor T1 and the voltage applied across it. So potential drop will be like positive when this terminal is positive, current will flow like this, and this is plus and this is minus, and the convention also is the this plus and minus. This is plus minus, and I mentioned this convention plus minus. So potential drop is positive from here to here. When thyristor is off, thyristor getting off. When getting off, when the cycle become negative. When thyristor is getting off, that time cycle is negative. So at that time the voltage appear, this voltage will appear, this one, because at this time is only the thyristor is off. So like this. Again for negatives, at this is the negative cycle, this one is the negative cycle, this is negative, means this terminal will become positive. So this terminal become positive for this, this is negative, so potential drop will show in the negative. Again it is positive, again. Okay, फिर से ट्राई करते हैं. Okay. So for positive cycle, in this, when T1 is on at theta equal to T1 is theta equal to alpha, T1 is on, so T1 is on from alpha to, suppose this one is the beta, this one is the beta, extinction angle, this is called extinction angle. So alpha is on from the thyristor T1 is on from alpha to beta. So potential drop across the VT1 will be the like positive potential drop VT1 will be appear. Okay. Now for negative cycle, when voltage become negative, for negative cycle, this negative voltage will appear, this one negative voltage will appear, and for positive cycle, this one again positive voltage will appear. Similarly, for VT2, when thyristor is at this condition, when V naught is 0, no one is getting on, कोई भी T1 T2 में से कोई ऑन नहीं था, ठीक है, ये पॉजिटिव था, ये पॉजिटिव था, ठीक है, तो जब ये पॉजिटिव था तो इसके रेस्पेक्ट में ये नेगेटिव होगा, सेम जो भी ये है इसको हम रिवर्स में ड्रॉ कर देंगे. So for VT2, this one is the voltage across the thyristor T2. Now write down the voltage equation. Average value of output voltage. This waveform current or voltage is same, means symmetrical, so average output voltage is 0, average value of output current will be also 0. Now find the RMS value of output voltage. RMS value of output voltage. VOR square 1 upon pi 1 upon t 0 to t Vm square sin square omega t d of omega t. Okay, so when you make this V naught square, this will be same, means this will be like this. When we make it square, this will be like this. Okay, this will become like this. So time period for this waveform will be pi. Time period for this waveform will be pi. So equation will become 1 upon pi 0 to pi Vm square sin square omega t d of omega t. So here we see that output voltage is appear from alpha to beta. We can integrate this. What is the VOR? VOR is the area of output voltage. So you can integrate from here to here, or you can integrate this equation from this waveform from here to here. So it is easy to integrate this waveform from here to here, because we don't know what is the angle of this. We don't know what is the angle of this. So that's why we integrate Vm square sin square omega t from alpha to beta. Let's integrate. VOR square equal to Vm square by pi alpha to beta sin square omega t d of omega t. You can also write Vm square divided by pi alpha to beta 1 minus cos 2 omega t divided by 2 d of omega t. Vm square divided by 2 pi alpha to beta 1 minus cos 2 omega t d of omega t. Again you can write, integrate it, it become Vm square divided by 2 pi and beta minus alpha and plus sine cos 2 omega t becomes sine 2 omega t, then sine 2 alpha minus sine 2 beta divided by 2. This is the VOR. Now VOR final equation will become like this: Vm by root 2 beta minus alpha plus sine 2 alpha minus sine 2 beta divided by 2 and whole divided by pi power 1 by 2. Now find the output current. Let's find the output current. So from the equation, from the circuit diagram, this one is the circuit diagram. From this circuit diagram we can write that Vs equal to R into I naught plus VL. Okay, for load current I naught, Vs equal to VR plus VL. You can write R into I naught plus L d I naught by dt. From where omega t is greater than alpha and less than beta. Okay. Now solution of this equation, will be Vm divided by Z sine omega t minus phi plus a e to the power minus r by l to t. This is the solution of this equation. Okay, you can easily find this solution from this equation, no problem. So this component is called steady state component, and this one is called transient component. Okay, so here this Z is root of R square plus omega L square, and phi is tan inverse omega L by R. So find A. Find A. For A, to find A, so A, suppose I naught is 0 at omega t equal to alpha. At omega t equal to alpha, I naught equal to 0. Okay, so let's put it down in the equation. Vm by Z sine alpha minus phi plus a minus r by l into t. Put the value of t here, so it will become equal to Vm by Z sin alpha minus phi plus A to minus R by L into T is alpha by omega, so this will become alpha by omega. Now A e to the power minus R alpha divided by omega L equal to minus Vm by Z sin alpha minus phi, sin alpha minus phi. A this A will become minus Vm by Z sin alpha minus phi divided by e to the power minus R alpha divided by omega L. E equal to minus Vm by Z sin alpha minus phi e to the power R alpha divided by omega L. Put this into the main equation, then I naught will become Vm by Z sin omega t minus phi minus sin alpha minus phi e to the power R alpha by omega L into e to the power minus R L into T. Vm by Z sin omega t minus phi minus sin alpha minus phi e to the power R by L bracket alpha by omega minus t. So this is the equation, output equation for single phase full wave AC voltage controller with RL load. Thank you very much.